All right, guys, on this next section, we're going to be looking to define and explore. I want you to write down these words in your worksheet. Quadratic equations are polynomials that follow the form. Now, you're going to have to, I type these out here, but you're going to have to copy them on your own on your worksheet. Follow the form ax squared plus bx plus c equals 0, where a, b, and c are constants. Henry, I'm recording, okay? So can you be quiet, please? Thank you. Are constants, or just like a number, okay? And it's important for quadratic equations where the letter a, or the coefficient, I think I spelled that, if efficient, the coefficient a cannot equal 0, okay? So there always has to be some number, a non-zero number, as the coefficient for x squared. It could be 1, it could be 1/2, it could be 15, but it can never be 0, okay? This little red symbol means not equal. Okay, some important features are a variable term with an exponent of 2. So this means that you have to have like an x squared, or an a squared, or a y squared. Usually, well, they're not usually y's. They're usually x or a squared or c squared, but it has to have the power of 2. It has to have some variable raised to the power of 2. Okay? And some other important features are that if we graph them, let me write this down in here, a little change of color here. If we graph a quadratic equation, I'm going to write EQ for short, EQN for equation. If we graph a quadratic equation, we get something called a parabola. We get a parabola. And those can be things that, if you look like this, here's a graph, and a parabola can look like this, kind of like that U shape, or it can even be an upside down U, something like that, okay? Please write everything that's in this box on your worksheet. Even copy down the stuff that I typed here. Well, now that we kind of defined some mathematical terms for quadratic equations, where do we actually see these things in real life? Okay. Well, here's one place, one of my favorites. Where do we see them? Quadratic equations, I'm right here. Quadratic equations are used to design and build things, okay? I forgot used here. Let's add that in. Are used to design and build things. So engineers, scientists, people who are working on this kind of stuff can use quadratic equations to model how to build roller coasters. And think about it. If you've ever gone on a roller coaster, you usually ride the track out and then you go to some big high mountain top or some big climb, and then boom, you come down so fast on the roller coaster, and then maybe even you do a loop, okay? At the end of the day, look, this shape right here, it's kind of the same as a parabola, okay, where it is a parabola. These can all be modeled by parabolas. So we use quadratic equations to model roller coasters. We can use them to model flight trajectories, which are the same as a flight path for rockets and spacecraft. So check it out. If you launch a rocket from Earth, it goes all the way up, goes high, 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 and then it comes back down, and it's making that parabola shape when it comes back down, okay? For rockets that go into space, they come up, follow that same parabola, but then they kind of just keep going to forever, okay? And that's a kind of different kind of equation that we're going to look at later on this semester. But notice this parabola shape where it comes up to a peak and then it comes back down the same shape but coming back down. Okay? Airplanes and fighter jets uh, also follow flight patterns that can be modeled by quadratic equations. So let's say you have a little jet engine here, or a little jet fighter plane or something, and it's flying. It can go same thing. It's going to go up when it takes off, and it's going to go up, 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 and then eventually come back down, and then maybe do some spins or whatever like that. But some of these portions of the flight path are modeled by quadratic equations. Look at my little plane. All right, there's another space, not just in engineering and science, but statisticians and business owners, financial analysts, and people who work in those kinds of areas can use quadratic equations to model and predict investment and business growth. So look at this graph. This is like a graph that we might see in our class, but we got an x coordinate and we got a y coordinate, and we're just representing here, we're representing the amount of things and quantities, and here you've got profit, revenue, total costs. Someone that studies business or finance can explain exactly what this graph is, but what we're going to focus on is, look, this profit line follows a parabola shape. And then this revenue stream line follows parabolic curve. Okay. So these are some areas where we would actually apply or see or use quadratic equations. Please make sure you write everything that's on this video. Copy it down onto your worksheet, please. These, you don't obviously have the drawings, but you can draw a little sketch. You don't have the drawing, but you can draw a little sketch of the parabola. Okay. Or just like I did here, you can just draw a little sketch and make some little notes and some annotations to yourself so you know what and where we're talking about these things. Okay.